Hello everyone, my name is Martin Glasowski. I work as a senior researcher in IT for Innovations, which is the National Supercomputing Center of the Czech Republic. And it's my pleasure to welcome you on the 7th training of the IOC project organized by us, by IT4I. And this training is focused on JUBE benchmarking framework, which is, in my opinion, very impressive. And our tutors today are Thomas Breuer and Yannick Miller. Thomas is the lead developer of the JUBE, and Yannick is also one of the engineers who are working in JUBE, and both of them are from Forschungszentrum Jülich from Germany. Let me quickly share with you the overview of the timeline we have for today. We begin at 1 p.m. with some introductions to JUBE and its application inside the IOC project. Then a quick overview of the basic features will follow. The coffee break is at 2:15 p.m. and it will last for 15 minutes up to 2:30 p.m. Central European time. And then we follow with the overview of some advanced features. And then real examples of JUBE applications, and the Q&A session will be at the end from 3:30 to 4 p.m. Now let me give you a quick overview of what the IOC project actually is. So the IOC project is part of the C family of projects funded by the EuroHPC, and the C projects are focusing on the modular supercomputing architectures, which is being now, let's say, in huge focus of the EuroHPC joint undertaking, which wants to build supports building exascale supercomputers in Europe. This is also in cooperation with many other European projects, namely the EPI, the European Processor Initiative. And the IOC project focuses on the storage aspect of the modular supercomputer architectures. And the other projects are, for example, DeepC, which focuses on new programming models on top of new computer and processor architectures which are coming now, and also the RedC, which is focusing on creating the European network solution, the European interconnect for HPC clusters. So the IOC project partners are basically all across Europe. In this training, you will see our colleagues from Forschungszentrum Jülich from Germany. The project is being coordinated by CEA from France, and this training is co-organized by IT for Innovations from the Czech Republic. Quick overview of the goals of the IOC project is to build a essentially hierarchical storage management solution, which tries to target all the different levels and technologies for storage we have there, starting from, let's say, the cheapest and slowest one, technologies like tapes, which can be used for archivals. Hence, you can see that we call those data frozen at this level, and coming slightly up to the object level storage, where the data are becoming, let's say, slightly warmer, where technologies like classical spanning HDDs are addressed, flash drives, also NVMe, NVMe drives, and persistent RAMs are addressed, and all the way up to compute nodes and caching mechanisms, where we address, let's say, the most, let's say, burning data, which has to be moved quickly. And the IOC tries to target movement of the data between all those different tiers in order to help the HPC applications use the modular supercomputers more effectively, and to basically be able to move the data between different modules of such supercomputer in an easy way and efficiently. So this would be it. Thank you very much. Now I will pass the floor to our tutors.
So welcome everyone. We're going to talk about JUBE today, and in the context of IOC, but JUBE is quite a general framework, so it will be mostly independent but we show some use cases and how we made the best out of the strengths of JUBE. So yeah, we are already introduced, so I don't need to say much. Thomas liked to refer himself to maintainer. I'm what did this of JUBE, and I have written a lot of JUBE scripts, and basically explored how to best use JUBE in the past. Will be about lots of basic knowledge, so this will be quite useful for you then for JUBE. And then the later part is maybe then something to revisit when you have some more experience with JUBE. And for those who have already used JUBE, the later part will be probably the most interesting to improve your usage of JUBE. So we use XML or YAML to describe, so it would be good if you can already read and understand this a little bit. Otherwise, of course, this is all in the context of HPC, so a little bit knowledge about HPC systems would be helpful, and we're using Python here and there. But yeah, we start pretty basic, so as long as you can read everything on the slides, you don't need to know much in advance. So we will learn JUBE features. And additionally, we'll see a little bit of the limitations and how to deal with that in JUBEs and how we used it in the IRC project. So let's start. Can I get the JUBE? Do you see my controls? Like here. Can I move the scroll to my first screen? Yeah. Okay. No. So JUBE in a nutshell. So you probably all have worked with applications and data in some form. So that's where we start picking up. So when you use JUBE, you have your application and your input data, and you additionally write a JUBE configuration. And JUBE will take this configuration and the data that you described in the configuration, and then do some workflow with it. So in this case, the workflow is consisting of a compile step, where it does different compiles depending on with different settings here, optimization level 01, 03, and then an execution step, where again it does different settings here with 2000 CPUs up to 8000 CPUs. It submits all those jobs, wait until all those jobs are done. The jobs produce some log files. In these log files, there's probably some metric that you want to know about. And JUBE extracts those metric, and at the very end will print you this nice table. And everything in between can be fully automatic if you like. So you start with a JUBE script, you say JUBE run, and if you want to fully automate, then JUBE auto run, and you'll end up with this table. And yeah, that sounds great. And here's a little bit more of how to get there. So generic is a lightweight environment, and yeah, very generic and configurable. So it's not to any specific applications. You can run, monitor, and analyze your workflow executions in a systematic and reproducible way. And it's kind of a replacement for scripts that you might already have written for yourself in Python, Perl, or shell scripts that automate some tasks around doing studies. It can be used for benchmarking. That's the main idea. But I would say it is generic enough that we also use it for different stuff. So aside from benchmarking, parameter studies are also very obvious thing to do with JUBE. I specifically have used it also for testing because the reproducibility here is very nice, and the interoperability with the HPC system. But you might also use it in production scenarios where you just want to rerun a specific workflow. And if you're already familiar, that's probably a good application for JUBE. Some things that JUBE are not. So even though it's in the context of benchmarking, JUBE is not a profiling tool. So it's not like a score P or anything. All the metrics that you want to see, you have to extract with tools that do that. So we just grab, or JUBE just grabs the metrics that are in the log files, for example, and organizes them for you. But you have to make sure that your run actually produces those metrics. Also, it's not a building tool. I showed you just a step, a workflow where we had a build step. But in this build step, you would invoke whatever building tool you usually use to build your software. So yeah. And also, JUBE is not completely free lunch. Like the writing of the JUBE script, yeah, that's why we're here. It needs a little bit of training and a little bit of time and effort. But after that, when the optimization takes over, every time you use the JUBE script, you save a lot of time. And I would say even more time you save when you don't fall for the typical traps in doing studies, etc., that would happen without the optimization. So you've probably seen this picture here in some different contexts. It's reused a lot. So I would translate this here as we're not writing the code here. Maybe we're, for example, doing a parameter study, and then we done the study, but we're confused. The results don't look like we expect. So we're like, okay, what's going on? Did we really do the study as expected? Are the results that weird? Did something wrong about our model or what? And then in the rethinking, well, we find out, oh, maybe we mixed up some results were not from the runs that we thought them to be. They had actually other parameters or input sets or whatever. So maybe it was not even that the results itself are wrong, but just hard to keep track of everything and putting everything into correct context. So an application developer in IOC writes a JUBE script because they are the experts for their application. They know how to build it, how to run it, what parameters are interesting to study, what metrics in the output are interesting. So they can use it as we said for the studies, or let's say for a basic stable setup that they can test, especially in the IOC context. We are adding new hardware and new environments. So it's very nice to have a JUBE script that you can just run again and know, okay, on the previous setup, this worked. Let's see what happens on the current setup. And yeah, because you often end up in a case where you're like, okay, something's not working, but I'm not sure if I followed all the instructions from the last README that I got via email correctly, because yeah, environment changed again. So for this case, it's very nice to have JUBE just as a basic stable setup. And of course, we use it for benchmarking. That's where I have the most experience in this project. So the benchmarking team can, for example, use the JUBE script and run it in a regular setting. Here we use the CI/CD pipelines to regularly run the benchmarks, and we don't need to become experts on the application at all. We just know how to use the JUBE script. That's all we really need to know, and yeah, that makes the job for us much easier. And we also found another use where we do it basically the other way around. and that is where the benchmarking team is writing some partial or complete example scripts, showing some, let's say, synthetic, very simple software how to use in the new hardware context. And then application developers can reuse these scripts and customize for their application. Yeah? So, for example, dealing with the environment, we show how to do that in JUBE, and then everybody can redo. Here is, that is not a JUBE script. This is an example, what I was just talking about, the CI/CD script that is uniform for us. So here is an example how an CI/CD script in IOC looks like. And basically, this is the only line that changes, really. The rest is the same for all, or almost the same for all applications. And he would just say JUBE autorun, and yeah, then afterwards we collect the results. So that is a really nice abstraction level that we have here. Okay, so enough of introduction. Let's actually start with some basic features. If you have seen previous JUBE talks, this is still quite similar. We will go basically in a complete example of IOR. So we will build the whole JUBE script until a realistic stage, and bit by bit add the pieces that you need. We'll stick in this example to XML, but as I said, there's also YAML available. We will go through that later. It's just the slides are really nice, and I don't see to do it for both languages at the same time. A very simple JUBE script is just declaration, hey, I'm XML, I have a root tag JUBE, and then I describe some very basic thing, a name and the path where I want to run. And there's one step in here, and this is already a complete JUBE script. This one step says, I want to do something, I want to execute IOR. So for keeping the example simplified, we assume here that IOR is in the path. We show you later on how to build and then use the build binaries that are probably not in the path or something, but here just to keep the script simple. So if I run this script with the command JUBE run IOR XML, this is the output I would get. This is my run ID, so I can run the script multiple times, and it will get a unique ID every time. And yeah, we will go through the rest of the output a little bit later on. For now, just see there's one step being executed, and it's already finished. It's done. And yeah, I mean, not much in the script, so not much happening yet. But under the hood, there's a lot of things happening. Now, a little bit of warning. This is the current state of JUBE. This is somewhat internal. So this might change in the future. For example, we plan to replace a little bit of the generated files here by a database. But for now, this is the current state. So if you want to have a look what is happening inside JUBE, usually that helps learning, writing the correct JUBE scripts. This is how it looks like. So we start at the run folder that we specified where we want to run JUBE. Then we have for each run ID a folder. And then inside the run, we have for each step and each execution of the step. So there was only one execute step. So there would be only one folder, but if you have multiple parameters for the same step, there would be first 0, execute, and then 0, 1, execute, and so on. And then in these directors is where the commands are actually in the work. It's where the commands are actually being run. So here you would see the output of the IOR command in standard out and standard error. Okay, so now let's add what I was talking about. The most central theme in JUBE is parameters. Yeah, so here we add a parameter set and two parameters called block size and transfer size. And for transfer size, we give three distinct values separated by comma. So that is telling JUBE we want to run 3 times with each of these values once. And we can use the parameters that we defined here by first declaring the use clause here or the use tag inside the step. So now this makes the parameters set known to the step. Now inside the step we can just use $ and then the parameter name. Notice this looks very much like an environment variable, but it's not. If you want to use environment variables, you can, but then you have to use double $. So since this is the most common usage, the single $ is reserved for JUBE variables. If we run it again, we see something has changed. We now have 3 individual runs. It's all the same step, but in 3 different parameter variations. And yeah, as before, nothing special yet happening here. A little bit more to the parameter. The parameter, as I said, very essential and can be used in a variety of ways. What we will see later, it can be used in the JUBE config script itself. For example, in the active clause, we define that a tag is only active if a specific parameter has a specific value, or can be any other usage of this parameter. You can use it inside other parameters. So you can decide, say, okay, parameter 2 has the value of parameter 1 plus 4, for example. You can use it in the do part, where we just said IOR, but it is any shell that you can execute there. You can, for example, echo the parameter and see in the stat out what your value was. And also in the text substitution, we haven't introduced it yet, but we'll see later, where you have a placeholder, and then you can replace this placeholder by the current value from the JUBE execution. So this placeholder would be put in a file that you would like to use, but with specific parameters inserted. And last but not least, you can export your variables to environment variables if that's easier to handle. Okay. In the next step, we're adding files. And so files that are, so for example, here we have the IOR binary. Instead of it being in the path, we now assume, okay, we have a binary built somewhere and we'd like to use that. We declare a file set. We call it source, and then we copy, in this case, all the IOR to wherever the working directory is. And JUBE will take care of this question, where is the working directory? Because as I showed you, it's depending on the step that you're currently executing, the benchmark, how many benchmarks you have executed before, but you don't need to worry. You just need to define, do you want to copy everything or do you want to link? These are the 2 options. And then you can use, like before with parameter scripts, put it in the use clause, make the step know about this file set, and then there will be a subdirectory called source, and in this you'll find everything copied. yeah, here just a hint. So in XML, you need to write some special symbols in encoded, so that XML does not mistake them for text symbols or something. In YAML, you can get around this easier, I would say. There are less symbols in YAML that you need to take care of, and more easy ways to encode them without writing hard to remember code. Also, we have a second step here. We want to execute the second step only after the first step is finished. Therefore, we add the depend attribute and depend on the previous step compile. And here in the do, you can see how we use this. So we depend on compile, therefore we will have a subdirectory compile, just a link to this other step. And in this compile step, we are using the IOR file set. So there we will have a subdirectory called IOR. So yeah, we here assume that we show here how to use these dependencies. So the links will be set up by JUBE, so you only need to use them here. Now if we execute this script, we'll have two steps. The first step, compile, is not dependent on any parameter sets, but only on the file set. Therefore, it is executed only once. And the execute step is using the IOR parameter set. And as before, this has 3 total variations, so it will be executed 3 times on top of this. Now, so the whole idea is to have parameters, steps, and define the dependencies between those steps. And then JUBE will correctly expand the parameter space and also deal with combinations of parameters, and will at all time remember what parameters are being used for this run. So here we have another example with 3 parameter sets. One is just defining constant 0. Then a second parameter set, comp set, is defining 2 values. One is defining one parameter named P1 with 2 values, A and B, and the exact set is defining P2 with values 1 and 2. Now you need to see which set is used in which step. So we have the preprocess, which uses the preset set with only 1 value, so it will be executed only once. Then we have step compiled, which uses the comp set. Now the comp set has already 2 variations, so it will be executed 2 times. And then we have the execute step, which is depending on both of the other steps. And also it is using the exact stats. So now for the depend itself, it will already be executed for every combination. So with const 0 is not adding any combination, so there will be the combination const equals 0 and p equals a, and const equals 0 and p equals b. So this is already 2 executions coming from the dependencies, and then itself is using the exact set, and that again has 2 variations. So in total here we see 4 combinations. Our JUBE script is growing again. We're now adding pattern sets. So now we're focusing on, we have done already the parameter expansion. We have done a build in an execute step. And now after the execution is done, we want to know something about the results. Therefore, we define some patterns. So here we have only one pattern set, one pattern called write bandwidth, and we work with regular expressions to find in the output that reproduced the values that we are looking for. As you see here, it says write /s plus JUBE fp $. So this JUBE fp is something that comes with JUBE. So we have predefined the most common regex expressions. This one is standing for floating point. Yeah, this is looking for some write followed by an underscore and then followed by some empty space and then followed by a floating point value. And then we define where should this pattern be looked for. So we define an analyzer. We use the pattern set that we just declared. And then we declare how to analyze which step, first of all, it is. So only the execute step needs to be analyzed. There's nothing in the compile step that we want to analyze. And what is the file called? So here we want to analyze the standard out file. And lastly, we define how to view our results. We show the table, and we have the possibility to make tables or to put the data into database, but for that I don't have a slide yet. So here we define a table just called results, say style pretty, and then we say transfer size and write bandwidth. So transfer size is the name of a parameter, and as I said, JUBE always remembers all the parameters, yeah, that are being used for the execution. So we can print them out here, and we probably want to print out the input parameters. And then write bandwidth is the pattern that we hopefully successfully extracted from the stood out. And now if we do that, here we run and we already tell JUBE, hey, when you're done with the JUBE run command, also analyze and show the result. And here we have the table. So these values are coming from some log files where IO was run with the parameters on the left and the write bandwidth on the right. And yeah, as you see here, if somebody's using this and doesn't know about IOR, I mean, we didn't have any flags for IOR yet, but we can put all of this in the JUBE script, and the user at this point only needs to know, okay, how to run and then how to interpret maybe the results. Yeah, a bit more to the pattern extraction itself. Regular expressions are very useful, but also somewhat hard to learn and read for humans. So I regularly recommend something like a website regex 101 and put it in Python mode to be exactly yeah, in sync with what we are using here in JUBE, and then you can experiment. So here's a picture how the original log file would look like. So it's kind of printing a table here, but what we know, okay, there's this read, and then there's some white space. Yeah, we don't know exactly maybe how many. I mean, we could count here, but we don't know if that's fixed or not. And then the first value will be the one that we're looking for. So here's the complete regex that would match correctly. And this is something that you can test on regex 101. And then Specifically, the one in green is something that we would have predefined in JUBE, so you don't need to write this part, only the surrounding part. In our example so far, we have just executed IOR locally on whatever node we are. Of course, this is rarely the case. In most applications, we want to run jobs on an HPC system. Now, JUBE has no direct knowledge what an HPC system is or how it works. We have a bunch of templates for different HPC systems. The most common one is probably Slurm. In our examples, we'll assume Slurm, but we have also support for other systems. I would actually need to look it up. I think something like PBS, Torque, I'm not sure. But what JUBE can do is JUBE can support asynchronous commands. So if you submit a job, your submit is done instantly, but the job is not finished after the submitted job is finished at unknown time point, and you probably don't want to wait for this here, but at some later point you want to continue with your workflow, and JUBE can do this if your job script is written in a way that when it's done, it will produce a marker file, and then JUBE will just look for this marker file and understand, okay, the marker file is now there. That means the job has finished. That means I can continue running the workflow. So this is the standard usage. You run JUBE run first, and then you run JUBE continue maybe multiple times, and in the end you would JUBE analyze and in fact also JUBE result. How do we define a asynchronous job and use these templates that I talked of in JUBE? So when JUBE is installed, there will be some platform XML in the JUBE coming with JUBE itself. So for us, it's in the JUBE include path. And if you're on JSC systems, for example, this is already in your path. So nothing needs to be done here, just init with platform XML. This init with is telling this parameter set that it's not starting from scratch, but it's instead starting from whatever is written in platform XML. And then you can override values, you can add new values, etc. But basically, this will expand to much more, everything that's in platform XML plus this on top. Yeah, then we override here. So for example, we do multiple nodes. We have 8 tasks per node. We define our executable. Before we would have done it in the do script, we would just run the executable. But here we want to create a job script that runs the executable in srun, for example. And then we have some additional exec parameters that we defined here. And then in the step, we have 2 new, or in this case, 1 new attribute, that is the done file. And the value is just $done file, and you don't need to put anything else ever, really. So this done file variable is again predefined in our system parameters. And the same is true for the submit script. So just your do will basically always look the same, $submit/submit script. And if you're on a Slurm system, this will then be spatch, and this will be our standard name for the submit script is I think, submit.job. Okay, here's the other way around, but yeah, and the submit script will automatically create a done file, and JUBE will wait for this to understand that this step is finished. Now we don't want to analyze the standard out anymore, because if we do, the standard out will just contain whatever the S batch has written into it and not what the job has written into it. The job has defined its own output file, and here is called job.out. So also we fix this in the analyzer. Now, if we run it, we see that this time our jobs are not done yet. They're instead at the wait status. You can see this first of all here in the table, and while the table is not there yet, so basically while JUBE is still running, the line above it is like a progress bar. So you can see JUBE is doing something, and for every step it will either print a bunch of hashtags, which means it's already done with the step, or a bunch of zeros, which means, okay, it's in the wait state now, or a bunch of errors. So if you have lots of steps and it starts printing lots of errors, you can probably then Control Z at this point and wait until it's done crashing all the steps. But if you see zeros being printed, it means, okay, it's still running, still working, and it will end up with jobs that are in the queue. After this JUBE run is finished, you can always use the JUBE continue command, and here again with the -r parameter to tell JUBE if you're actually ready to continue, then continue all the way to the result table. And in this case, there was long enough time between the JUBE run and the JUBE continue for all the jobs to finish. So we see the result table here. So this is like, yeah, basically what I just described in a chart. So the first step was not asynchronous, so it is always either finished or crashed at the end. But the second step is asynchronous, so it's submitting a job, and we don't know exactly when this job is done. And then with JUBE continue, you check for the done file, or alternatively, you can also, the same way you add the done file, you can also add an error file. So it's checking for either of those two files. And once the file has been created, as soon as you run the next continue, it will complete the step and continue with the next step. Okay, so the templates that we just talked, they serve two purposes. One is just to not having to rewrite the stuff all the time from scratch, so it saves a lot of time. But the other main idea is to be more platform independent. So as you can see here, it's again highlighted. The do script, the do step just says submit script, and there's no notion here of this being an S batch. On our systems, it will resolve to an S batch because we have Slurm, but in other systems, it might resolve to a different command. And then you can use the same JUBE script on different systems, and the correct template will be used, and a different kind of job script will be produced, and there you go. You can now have one JUBE script for multiple systems that have a different scheduler. So that's very handy. There are a bunch of, there's like job templates called submit.job, and there's a bunch of parameters predefined in platform XML, and you can see those files or you can make those files visible if you either export the JUBE include path to the place where these files are, or if you do JUBE run --include path, or you can also at the beginning of your JUBE script, you can also add the tag include path, and yeah, these are 3 out of 4, I think, variations to make JUBE aware where these files are. And again, I would say if someone is installing this for other users, you should probably just resolve to the first version. And for example, for us, we have a module. So if you load this module, this JUBE include path is exported, and you're good to go. Now here is the same step from that we ended up with, but in YAML. So for me personally, this looks cleaner because it's more focused on the content, but they are completely equivalent. So it's due to personal preference which one you want to use. So we have seen the JUBE run and the JUBE continue, and I hinted a little bit to the other commands. So they are mainly those 4 commands: JUBE run, JUBE continue, JUBE analyze, JUBE result. And then there's one command that will run all of those commands after another and repeat to continue as often as necessary in an interval. And that's called JUBE autorun. So that's what we've seen in the CI/CD script at the beginning. Yeah, I don't think I want to show much more about the individual command line access command lines. They're all documented. If you do JUBE continue help or the other way around, I think JUBE help continue. I'll see. Then it will tell you all the options. So the first one, JUBE run, takes the script, the JUBE script as input, and all the following commands, continue, analyze, result, take the directory where the JUBE is executed. And this also means that basically if you change your script afterwards, it does not have an effect on the continue, analyze, result, because it's working with the version that is inside the run directory. The one exception where you might want to change this is for analyze and result. If you have all your results, but your regex don't match, which happens, you can fix the regex and then do the analyze and result step with this new script where you fixed it, so you don't have to run all your experiments. Yeah. So our documentation and tutorials are here under ulish/jsujube. Here's also the help command I was just talking about. So either JUBE info benchmark there. This is for info about the benchmark itself. JUBE help, and then keywords. And this is more than just the commands. This can also be, I think, anything that's in our glossary. So anything that is like an official term in our JUBE tutorials. And you can see the log files that JUBE produces with JUBE log, and you can run in a debug mode where basically there are no jobs being submitted or anything, no do's being executed, but it will try to expand the parameter space and resolve the dependencies and etc. And then you can safely see if this looks fine, and you can continue with your main execution, or if this already breaks, then you don't need to continue. So this saves you from accidentally submitting lots of jobs that are all broken or something. And if the logs are not verbose enough, there's also your verbose version. To use JUBE, not much is required. It works on any Linux. You use Python 3.2, and if you're a YAML user or want to have YAML users, then need to install PyYAML somewhere. And if you want to contact us, for example, so any help, then we have an email list, jube.jc.jülich.de. If you are on our systems at JC, then you don't need to worry about it. We have a module, just load JUBE, and it's a little bit different. I think on Deep it's actually necessary, but on some other system it's not. I don't know, the D modules are not exactly the same. So sometimes you need to explicitly load the PyYAML module, sometimes you don't. Yeah, but this is just for JC users. And as I said, for us, the JUBE include path is already set up. So you can check the templates under the following path, but actually later in the advanced section, I will do exactly this because I think it's very helpful to know what is the exact content of those files. So there's a little bit less magic and a little bit more like I know what template I'm using going on. And yeah, I think I rushed quickly enough to, in fact, be quite early at this slide now. So I will now take my time and see. Okay, there was not so much in the chat. Yeah, so let's make this a first stop where I'm asking for questions. Go back to some slides. Anyone has something? Okay. You can also just type "I'm still awake," so I know everybody's here. Because if nobody is coming up, there are some questions. Are there some tools to validate the execution went well? So yeah, depends how your validation looks like. As I said, we only have the you can do anything with regex, for example. You could check like for most logs, it's probably either some error or the result is printed. So if there's no result printed, then it probably went wrong. You can explicitly search for error patterns if you want. Numerical deviations, yeah, again, this is something you have to make sure that your application is printing information like this in the log file, and then you can include this into your JUBE result table. You could also, if you want to be really strict, you could add another step. So instead of using the analyze, you could use an extra step that is checking the deviation of the run step and errors if this deviation is outside of your accepted boundary, so you don't even get to the result table then at the end, or have a clear indication, hey, here's something wrong. But there's no built-in feature.
So yeah, I was typing that sometimes the one dependency, like whatever library, for instance, can have some impact on either performance or result validity. And sometimes you want to explore like building one dependency with a set of parameters and maybe a second one. And you might want to represent that. I mean, not mimicking Stack, but maybe a little bit. Spark or whatever tools to build dependencies. And you might want to build a matrix of many parameters for many dependencies. It looks like JUBE could do it with a lot of parameters and describing a lot of steps to build each dependency with each step. I don't know if there are some built-in things to help doing that, or if it's just used for the end binary that you have in the end that's already built.
Yeah, so let's maybe go to the very easy one, like this one. So what we have, as I said, the parameters are always remembered, and here the parameters are used in the execute step only, but you can also have parameters for the compile step, and add these parameters then to your result table. So as shown in the picture at the very beginning, here you would, for example, have two builds, one with O1, one with O3, and then at the end in the result table show, okay, I built it like this, ran it, had this performance, I built it like this, ran it, had this performance. Yeah, more complex stuff with libraries, as long as it's like dependent on some parameter that you can specify, seems possible. Does this answer the question?
Yeah. I'm just fearing the configuration file that gets pretty big, actually.
So you have a lot of different compiles then, with a lot of different variations, or?
Yeah, I mean, you can always find some new things to play with. Can range from, let's say, the CPU frequency to a library flag, to library version, to a number of processes, threads, binding policies, so many things. And
but I don't think the JUBE script will become big, because like this, for example, here, this is encoding the whole workflow 3 times. Yeah. So you get one more line here per parameter, and then if you have one parameter with lots of different values, they're all in the same line, just comma separated. So you get a lot of steps at the end. It might take a longer time, but the script itself usually still quite complex.
I see, and in YAML it will be even shorter. Okay, thanks.
Yeah, to be honest, I think the YAML has about the same length, but a little bit less encoding symbols. We'll see more of that later.
Maybe I can add something, Yannick, at this point.
Please.
So referring to this question, imagine if you have a second parameter like the transfer size here, which has also a comma separated list with 3 entries. Then JUBE will build a cross product of those. So you will end up in not within 6 steps, but in even more of them. So by just adding another line with a comma separated list, your parameter space can blow up and your script will just have just another line in it. And if you fear that your single script gets too big, you can still exclude parts into second scripts where you just manage your settings, and in the other ones you have your steps that are executed. That's how you can in the end you still have the same length, but you have excluded parts into another JUBE script that can be included by the main one, and the other one can be then reused in other settings, like the same mechanism as Yannick described with the platform XML file. Maybe that's also information that helps you to answer this question.
Yes, thanks.
So the next part is the advanced JUBE part. Now, after the quick questions at the beginning, lots of people here are new to JUBE. So for those, I guess the advanced JUBE part is partially interesting and partially hard to follow or hard to understand, like why is this important. But I mean, you have a recording, so feel free to come back to this part once you've experimented a little bit with your own JUBE scripts. And for the users that are already familiar with JUBE, I guess the JUBE tutorial was not so interesting, and the advanced part will be the most interesting stuff. What is the normal stuff and what is the advanced stuff? So this is, for example, if you currently go onto our website, there are two tutorials, one normal, one advanced, and we've basically covered everything in the normal tutorial. So we have done the input format. We've done much more than a hello world. In fact, we've done a real example. We've done the parameter space creation, step dependencies, quickly shown how to load files. And well, this substitution, we haven't shown it much because it really is for if you don't do anything fancy, it is all in the template. So we've just used this template and it did the substitution in the background. We have done the result table and we've shown help. Now for the advanced part, there are many features I could talk about. I think there are a lot of features that are either perfectly well explained on the tutorial and you don't really need anything else, or they're rather niche. There are few users who need those features or use them, and then most of the time you don't need to bother. But there are some features that are either more common or, let's say, just from the tutorial alone, still a bit hard to explain or to understand. And then there are features who are either not features in a sense, but more best practices, or are not even in the tutorial yet, which is something we're probably going to fix. And these are the types of things that I want to focus today. So from the many options that we are doing a schema validation because this is, I think, very helpful for any proper development setup. We're doing the scripting parameters because absolutely everyone uses these, I would say, and these are very important. Maybe even deserve a part in the standard tutorial. Scripting patterns are just the same, so we're not going to do it twice. Then statistic pattern values is something I don't have slides for. I just want to quickly say what it is, so you know it is there, and then you can check the tutorial, and I think the tutorial is absolutely self-explanatory here. So we have done the pattern extraction where you have only a pattern appearing a single time. But you might want to have something different. For example, let's say your application is also running 10,000 steps and every step says how long it took. Maybe you just want to know how, at average, how long a step took. So this is like, there is some output in the log file step time and it comes 100 times and you just want to average over those. You can do stuff like this in JUBE. So you don't have to you write 100 patterns that match one of each of these instances, but you can write one pattern that matches all 100, and then you can show the minimum, the maximum, the first, the last, the average, stuff like this. Then job system, I mean, we've shown that it's kind of in the background, but as I said, we will go over the platform XML and the submit.job.in in detail to understand what is going on behind the scenes there. Include external data is just a way to structure things. Like Thomas said, you can put your stuff into multiple files and then put these files together with include statements. That's why I'm not covering it. It's also explained and quite simple. And then tagging, I know it's used a bit, but I find it quite often that you think it's much more useful than it really is, and then you make it harder for yourself. So yeah, if you're interested in using the same file for, let's say, different variations of your benchmark, tagging is one way to achieve this. You can check out the tutorial. Personally, I'm not a big fan anymore. Platform independent benchmarking, yeah, we'll cover in more detail. And then, yeah, there's a lot more in here. Most of these fall under the category. If you check out the tutorial, you will know everything about the feature. So yeah. And then I'm going to cover a detailed, let's say, equivalence between XML and YAML. I would say using YAML and using XML are exactly equally as easy. So they are both basic. But apparently, for people that have used XML for a longer time and then swap to YAML, they seem to fall for a few cases. So that's why I've done this more detailed explanation how to swap in your thoughts, how to swap between XML and YAML, how to write the one or the other, how to show your colleagues who have only done XML how to do YAML, and vice versa if you want to. Yeah. And then the active clause, I've shown it here in the slide, but I noticed when doing this slide deck, it's actually not in the tutorials. No, so something that we're probably going to fix. But I show how to use this for multiple different problems that I encountered while writing JUBE scripts. So let's start with the first thing, that is schema validation. For both XML and YAML, we have schemas, and you can use those schemas to check your JUBE scripts for validity. If you are using an editor that has support in general for schemas, that should be most proper editors nowadays, then you can tell the editor where to find those schemas and how to apply them. And in this context, let's first say through those schemas you either get you on the one hand get additional highlighting, so you get the normal highlighting from XML and YAML, hopefully, but then you get additional maybe support for keywords, and it will check if you only use the correct keywords. I mean, common mistakes is probably something like parameter set or parameter sets. You just forget about it, or maybe you have attribute that you use in a tag where it's not existed in this tag, but you thought you just put it in wrong tag or something like this. Yeah, then it will highlight this. Also, you get auto completion, so you'll just be quicker. And yeah, in this context, I skipped over. In this context, I would also recommend to maybe name your files something like jube.xml or jube.yaml instead of just the XML and YAML ending. This allows then to apply both standard XML and standard YAML syntax highlighting and checking, and for files that end with this specific pattern, additionally apply the JUBE schema. Now, a scripting pattern was something where all the people that are here for the basic tutorial can still profit from. So we have seen just values in those parameters, but you can put more. We have 3 different modes: Shell, Python, and Perl. Yeah, Shell, Python, and Perl. And then instead of putting a value, you can put an expression in those languages that evaluates to a string value. And the string value will then be used instead of whatever you could have written manually. So here I have multiple examples that I find quite common or quite useful. For example, in JUBE, in Jülich, we have many systems. So I tend to have one JUBE script for all the systems. And then I want to know which systems I am on. And for our systems, we have the we have a file on in this /etc/f that your system name. Of course, it's not something that everyone of you has, but maybe you have some way of identifying. You can put some other code here, which system you're on. And yeah, so here I'm just reading this file, and usually it comes with a line break. So I remove this line break, and then the system name, I just have a clean representation of what system I am on. And then in the following script, I can use this system name to make proper choices for the system. For example, in the next one, I use the Python mode. I would say in generally, if you just want to make some dependencies between parameters, I think Python is the most readable, especially dictionaries. So dictionaries make it very easy to understand, even for someone who's not familiar with JUBE or not familiar with your application, to understand what's going on. It's just a mapping of here the system name is mapped to the QArch that is correct for the system name. So for example, if you're on Jules, we would have to use something like QArch equals SM70, and Eureka DC has some newer GPUs, so there it would be QArch equals SM80 and so on. So I have actually at some point shared my JUBE script with people. Yeah, so I found a bug and I sent them, hey, here's a bug, by the way, here's a JUBE script to reproduce. And they didn't know anything about my JUBE script, but they were still able to edit like some line of this. For example, if they are testing this on a third system that has now a fourth system that has, again, a different GPUs, they could probably understand, okay, I need to add my system here, otherwise it won't work. Yeah, and that's very expressive. Then also, this is more best practice to keep the topic of readability going. I like to use some intermediate variables. So I call intermediate all the variables that are not actually used in any of the do or anything. So it's not something that you see in any log output or in any script at the end. It's just an intermediate to get there. For example, this define QArch. So I could merge this QArch and define QArch here to say, okay, if I'm not using CUDA at all, the value is just empty. And then if I'm using CUDA and I'm on Jules, then I can put QArch equals SM70. But I think it's often more readable to not have like two indirections are probably okay. More than two indirections you probably never want to have. And then just put an intermediate variable that does this second layer of indirection, and then you have quite clean variables. And here's another strength for this type of parameter scripting. You can use the expressiveness and the conciseness of any language that you like to write bigger statements or more complex statements, or statements that you know are easy to describe with an algorithm but are maybe hard to type. So for example, all the powers of 2, and yeah, you don't need to calculate them by hand anymore. If you change them especially, you don't need to think, oh, was this again? Was 2 to the power of 10 again? Was it, you know? So yeah, here this expression expands to the following list. So I think the only thing that's maybe slightly a catch here, if you're new to this, here is the range expression, but the range expression itself is not something that JUBE could use. JUBE needs a string at the end, so you kind of need to transform the range into a comma-separated string. This is what the comma dot join and then with a range does. But yeah, and then again it's quite easy for you to change something when you have run, for example, until 25, and then someone says, oh, actually, at the 27th power of 2, there's some more interesting things happening. Maybe you should expand. Then yeah, just go here in this one number and change it. Okay, the next topic is the platform templates. Basically, I've just copied the whole content, how it's currently on the platform templates in here. So this is again the Slurm version, and if anybody is on a different system, then you can check your version manually in the Slurm in the JUBE folder in the source code. So here we'll see the templates that we used earlier in details, in why are they so, or how to use them, why are they so general that you basically don't need to use anything else unless, for me personally, I've found only one use case where I don't use these templates, and these are heterogeneous jobs. And I have put a feature request because I think we should have a second submit the job in for heterogeneous jobs. But if you use any other jobs, I mean, we have predefined all the common SPatch arguments here. We have in placeholder additional job config. So anything that's not already here, you can put there. So more SPatches or other stuff you can put here. If you want to prepare your environment by loading modules, exporting variables, changing your path, etc. We have env specifically. Then we have some preprocess. I guess the name explains itself. And then in the main part here, so after the preprocess, it's already checking, hey, was this successful? Because if not, I don't need to run the job anymore. It's just putting the error flag in. And then the central statement, we have a placeholder for measurement, so something like score P, yeah, for example. The starter is predefined to srun here for a Slurm system. And the arguments for the starter, so srun arguments, the executable name, and arguments for the executable. And then again, after running the job, it will check was the job successful. If not, put the error flag. Post process, and if everything's done, then it puts the successful done flag. So if you have anything in your JUBE script that somehow does not fit into this form, I would be very interested to hear about. So maybe just talk to us or make an issue how you describe why your script that you envision does not fit into this form, and then you can see if there's something for us to change about this template. And if not, I would say always use the template because there's a second advantage of using the template. Not only do you skip writing it, you get updates to the template that we do as JUBE developers for free. For example, when I started working here, the live version of JUBE did not have the error flag yet. It only had the done flag. So if you were using our template, then yeah, you didn't need to change anything because we changed the template so that it has this error flag, and you only need to set, okay, in the JUBE script, okay, I want to use the error flag now, and the template's already up to date. Then here's the platform XML. So this is where the mysterious predefined variables and values are coming from. This is not the full platform XML. It's a bit too long. So when you start writing your JUBE script with this, I recommend that you once take the time and go through it and see what is defined there, and also see what are the defaults. So which values do I have to set, which values don't have to set, and then you'll see that you have to set the absolute minimum, and everything else has some reasonable, hopefully, predefined. And yeah, what I want to cover here is which parameter set is what for. So where do you probably want to look for, and a little bit about what kind of things we have defined. So in the execute set, we have stuff that is, yeah, about the job script mostly, and or about chain jobs. In the system parameter set, we have stuff that is mostly about the system, and that you will also need in your SPatch script or job script in general. For example, here we have predefined our name for the submit script, but also for the flags, for the done flags, for the error flags, etc. We have something like nodes, tasks, queue. So anything that you see here in the SPatch with placeholders, we have a JUBE variable here for. So JUBE knows about these values and then can do the replacement. And yeah, there are some predefined wherever we could. So if you just want to run single node, single task, I think, job, then yeah, just to test, there's already predefined, and then you probably want to write some override these values for your production jobs. And then there's the execute sub, and this is where we define all the substitutions. So here we have these placeholders, hashtag, name, hashtag, and we want to replace them by JUBE variables. So here hashtag nodes, hashtag replaced by nodes. And most of these are of the form as I show here for the nodes. So it's just one-to-one replacement. There are a few historic dependent cases where the name is not exactly the same. So yeah, if you're not quite sure, then better double check what was the name. And then there are a few cases where we found it's actually pretty makes sense to predefine with a value that we calculate. So for example, the bench name by default will be your benchmark name plus your step name and your work package ID. Because if it's just a benchmark name, then every single job in this whole workflow will have the same name, and figuring out which job is this actually belonging to which step. So yeah. The template itself is called .in, and once the template has been replaced with all the values, the output is submit.job. So here you have submit.job.in, and then the processed version is submit.job. That is something that you could change, but I mean, it's just a name. I don't think anyone needs to really change this. And then at the end, the fourth here is the file set. This is just describing exactly this, submit.job.in. And yeah, so if you have these four, you can write basically in a JUBE script that produces in job script and runs this asynchronously. So this is somewhat similar to the IOR that we've seen at the end, but I've basically simplified it in, I would say, this is a perfect copy and paste template to start your first actual JUBE file. Yeah, because so these are the minimum number of parameters that you need to define yourself. For example, which account, so at least in Jülich, maybe on your system, you don't even need to define account because you just have access to the resources, yeah, by default, who knows? If you have multiple partitions, you need to define which partition are you on, or queue in this naming convention. And what is your executable named here, just host name. I wanted to make sure it's something that probably everyone has in their path. And then in the execute step, yeah, you use these parameter sets, the job files, the execute sub that defines the substitution for the job files, in the execute set that actually defines the values, plus you're using system parameters. And since the system parameter is something that you have here in your local JUBE script, it's just a normal use clause. And the other three parameter sets is something that you haven't defined yet here. So here you need to tell from where are you taking these sets, from platform XML. I'm taking these in there unchanged. So yeah. Then you have your done file, your error file, and as I said, the do clause is probably something that you want to look like this in every single JUBE script that you ever write. Unless you're doing something fancy like an IOC and have a workflow manager, then yeah, this might be subject to change again. But yeah, I would say I'll put this in the tutorials very soon because it's not there yet. And maybe in the next JUBE release, this is your go-to starter template. And now I will talk about the mapping between XML and YAML. As I said, YAML I consider as easy as XML or easier. I prefer YAML myself, but maybe the mapping from one to the next is not always entirely clear. So here's our get started file again with a little bit shorter. So in YAML, so both are a tree structure at the end. And to match in YAML, every unique tag, I'm sorry, here's probably some conversion thing going on. So every tag that exists only one, like the benchmark tag, there's on, actually that's not true, I realize, but in this case, there's only one benchmark tag, is mapped to just a YAML tag or a mapping in this case, where the key is the value, is the name of the tag. Yeah? And yeah, mapping in YAML is just key colon value, and then the value itself can be another let's say non-leaf node, so a mapping or a sequence in YAML, or it can be a leaf node or a scalar value of some form. Then the attributes, there are no attributes in YAML, and in fact, I would argue there is no reason to ever had attributes in XML, because the alternative for an attribute is always just a child tag. And that's exactly what is happening here in YAML. So it's a child of the main mapping, and the attributes are just key value pairs. So a value, a mapping with a scalar value. So here name and out path are children. Then the question is, what happens to non-unique tags? Because in XML, you can have multiple times the same kind of tag. So here there are 2 steps, which is perfectly fine in XML, but in YAML, a mapping is like a dictionary in Python. So every key has to be unique. So this is instead mapped to first of all, a mapping. So step itself is a mapping, but then the content of the mapping is again a sequence. A sequence is just like a bullet point list. So for every actual step, you have one child of step starting here with a bullet point dash, yeah, and everything behind that dash is then the step. So there again we have the name attribute. So this is again like the first key, the first children of the sequence element, and so should be fairly easy to see the equivalence here. By the way, this is all in the I think it's called block format in YAML. So you have in YAML two notations. You can write in a block format, or you can do an inline format that's a little bit more condensed. In an inline format, a mapping is like in Python a dictionary looks like, so angled brackets and then comma separated key value pairs. And a sequence, so also like a list, that's why here the list notation was a square bracket and then comma separated the gerunds. The next question is what happens to the content of a tag? Like the content is also in some way a child of the tag, but a specific one in XML. And again, in YAML, there is no such thing as a same as with attributes. There's no special attribute. There's no special text child. So it's just a normal child, and we just defined the underscore as a name here. So yeah, whatever is in the text part of the XML comes into the underscore key value pair of the YAML file. Here we have two children, and if you have no attributes and the text element, then you have only one children, which is the underscore, and then to simplify stuff a little bit, you can directly define the scalar value, and it is automatically be assumed that this is the content of the underscore key value pair. So here's a little bit of comparison, things that work well or not so well in the one or the other. We have seen in XML the text field, and the text field in XML is always just plain text. There is no way to encode this. Basically, you would have the JUBE developer to tell the JUBE developer, hey, I'm writing a specific coding here. Can you please do the processing for me? Because you cannot tell the XML this is now encoding. So this is different in YAML. The scalars have some built-in encoding mechanisms. So you can choose between plain text and interpreted one, which is very handy for any special symbols, but also for white space. I will show an example soon. So I'd say the text field itself is cleaner in YAML. And then we have comments. Don't know how many of you before this talk knew what an XML comment looked like. I didn't before I used JUBE. So yeah, this is an XML comment. It's not called angle brackets, like sharp angle bracket. And then exclamation mark dash dash. So it is basically a special tag. It has the same syntax as a tag with the special name exclamation mark dash dash, and then in between these start and end tags, everything's treated like a comment. So yeah, it exists, it works. You just have to know about it, and your editor might not have automatic support. Like I've seen some editors that claim if you do control and then some shortcut, and then they comment out a bunch of text. But I've seen it not work for XML specifically because of, I don't know, this. because it's somewhat uncommon, or because it's not multi-line. Like you can just put the comment symbol before each line, because you also have to put the end symbol for this comment. Yeah. So in YAML, comments are just a hashtag, like for example in shell or anything. So I would say this works fine. And then at the end we have debugging. So internally, JUBE only knows XML. So if you have an XML file, the XML, like XML format errors should be as clear as XML format errors usually are. And then if there are some JUBE specific errors where you have a valid XML, but it's invalid JUBE script, then I would say the JUBE errors are quite expressive and helpful. At least I found them to be. So I think with XML, the debugging is quite okay. And then if you have a YAML script, this is actually internally converted to an XML and then reprocess the XML. This means that it may successfully convert because the YAML was correct and the conversion worked, but then the XML was incorrect. And then it failed, and then you get an XML error even though you were writing a YAML file. This is of course highly confusing, and it's not even always the case that you can retrieve this XML translation that you had. Like at this point, you basically need to know exactly what converter is JUBE using to reproduce this file, because this file might not exist anymore after this error was thrown. So, I mean, you can often, by looking at what parameter, for example, the XML failed, you can check your YAML equivalent parameter and see, okay, here I did something fishy. Let's fix that. But yeah, at the end, this might sometimes cause a little bit of headache. Also, it might cite some lines or something where something failed, but this is again lines from the converted XML. So they are not related to anything directly in your YAML. You have to hope that it prints some surrounding codes and names that you can make sense of. Yeah, here's some examples where YAML mostly shines. So for example, there are 5 common symbols in, or some of them are actually quite common for JUBE scripts, like the greater or less sign. Every time you have like a Python expression with greater or less, you would have to encode them. Ampersand for shell script, like ampersand we saw before for executing 2 commands in a row, only when the first one's successful, have to encode. And then the quoting symbols, the single quote and the double quote, or the single apostrophe and the double quote. And in YAML, these are also like some special symbols, but here is usually enough to enclose them once in surrounding single apostrophe. So single apostrophe in YAML means everything in between is just literal symbol. I don't want you to interpret anything as an escape symbol. Yeah, there are no escapes. Of course, there has to be one exception. That's the single quote itself, because otherwise it does not know, is this the end of the single quote or is this an actual single quote? Like this is literally only symbol that you have to worry here. And this is encoded with this double single quote if you want it to be a literal. But all other symbols you don't need to worry. And I mean, that's pretty easy to remember, I guess. There's only this one symbol. Also, there's a second way to, or there are multiple ways to write YAML scalars. I like to refer people to yamlmultiline.info. It's a nice website that explains these options that you have with YAML scalars much better than the official documentary for YAML. So here I'm telling I'm using the block version again of a scalar, like a multi-line, and basically the scalar starts with the first text symbol after this. So the pipe symbol here is defining what mode exactly this is running, and I think this pipe symbol means that every new line is to be interpreted as a literal, so it is actually a new line in whatever code is coming out. And yeah, I don't know, maybe some more. And then the text starts with the first symbol, so with the less than sign, and you can have multi-lines. You have to start at the same indentation, and as soon as the indentation changes, the text is over. So here you have all the 5 questionable or difficult symbols, but none of them need any escape. And yeah, that's why I think it looks quite clean. Yeah, here's the same example with the XML comment again. So yeah, works in both cases, but guess you have to know. And here is the white space issue that I was talking about. It's not a big issue. It's just if you like clean code and clean files, then it's a bit annoying. And in XML, there's no way to, as I said, everything is plain text. There's no way to say, hey, this white space is only for me to make it readable. This is not part of the value. So if you in post-process, for example, something that will end up in your SPatch script, if you write something like this and you indent it so that is kind of correct for the XML, well, guess what? The indentation is taking literally and will go into your SPatch script. And depending, this is on the second indentation level, and I only use 2 spaces. But at this point, you might be already on the 6th indentation level. Maybe you use 4 spaces or tabs. And yeah, this shows up both in the SPatch script and also in the JUBE log file. So this I found confusing and annoying. So and YAML doesn't exist because, as previously said, the interpretation says it starts with the first symbol, which is the S of source, and then all the text that is indented the same line is also part, and all the white space is ignored before that, and the line breaks are again literal, so you have the line breaks to the next. You could also have a mode where you have a very long line that you want to be a very long line in your SPatch script, but you don't want it to be a very long line in your YAML script. There's a mode for that. You would change the tilde symbol into a greater symbol, and yeah, would have basically achieved the result where it says source link test bin event, and then this is actually in the same line, but here it would be in different lines. Just for comparison, here is the get started template in the XML version. Also here again, yeah, use this template probably. And then here's the same template in YAML. As I said previously, the length tends to be the same because XML is more efficient with the parameters in the same line, with the attributes in the same line, but then it's less efficient with the closing tags. But I mean, it's not about text efficiency at the end. It's not about how many lines you have in the file, but how well can you read it. So you can just stare at those 2 files and then see which one is easier for you to figure out what's going on, and then that's probably the language you want to use YAML in. Here's a nice usage of this case where you have inline notation. Yeah. So if you have block notation, this would just be instead of the brackets here, there would just be name, there would be no comma, and then on the next line, the same indentation would be the underscore. But to make it a little bit more compact and actually also very readable, you can make these nice lists of, okay, this is the parameter name, this is the parameter value. Yeah, and I think that's also something that most colleagues are doing like this, because no question, this is easier to read and also saves you some empty space on the like too much white space on the code. Okay. I think these are all things that the people that are quite new to JUBE can still understand and make use of. The next two and last two, I think, features or best practices that I show might be a little bit more difficult. So again, feel free to interrupt me at any time. And also the advanced users of JUBE, here, if you feel like I have too quickly or not explained why you would need something, yeah, I can understand. So feel free to interrupt. So here's the active clause shown. The active clause is something attribute that you can put into tags, but here it's in the step tag. It can be put into multiple different tags. I don't have a complete number in my head. You can, I think, if you go in the glossary, you can look it up, but I'm not even sure if it's complete there. Anyway, it basically says this step is only active when the expression here is true. This is only Python this time. You cannot choose your language here, but should be enough. So just then Boolean expression, and if it's not true, well, the step will not be executed. We said before, parameter and parameter combinations are cross products, which is maybe too much. And here I will show an example where the cross product is actually not what we want. And there are two versions to fix this. Is either by changing one parameter so that the cross product is smaller, or with the active clause. And I show you how I ended up in a situation where the first version was not possible, so I had to use the active clause. So here in my example, I have two parameter sets called build and run. And then I have one parameter, let's say it's called a stack, that can have the values GCC plus OpenMPI CUDA or GCC OpenMPI, different MPI. The values here don't matter. It's just important. Okay, this parameter has 5 values, and for the beginning, the other parameter has just 1 value. And then when we do when we use both in one execution step, so we have the cross product of these parameter spaces. And here, for example, the first column would be the build step, and then the second column would be the execute step. And this is fine for now. This is what we wanted. But then I went ahead with another step where I didn't. So in this step, let's say we build 5 versions and we see if all those 5 versions run without crashing. And in the next one, I wanted to do a scaling test additionally. So I had 10, for example, in this case, variations for the size. And now if I just use the script as before and change only the size parameter, like before it has a 1 and now it has 1, 2, until 10. And I use the same script, then of course I end up with 50 runs because of the cross-product expansion. And that's a lot, and that's not exactly what I wanted to do here. Of course, I was aware that this was happen. So the first thing I did back then is, okay, I need to change my build parameter here to have only one value. So I call it build 2 here because it's a different variation of my build set, build parameter set, and the scaling parameter set is still the same. So now I have 10 runs on what is for now then my default stack. If I run both steps now, so imagine the step where I test for crashing and imagine the step where to the scaling, then I have two basically independent trees because one is based on the first build parameter set and the second one is based on the second build parameter set. Now there's two annoying things. First of all, I have almost the same parameter set with one difference again. So yeah, you can imagine it gets more complicated to change the correct set, and a single source of truth is inviolated, so it probably make some mistakes. It's also unnecessary big. I mean, that's what we want to avoid with JUBE, that you have to double a lot of code. And also, I'm actually building the exact same binary or twice because I have the same stack once in my test all stacks and once is my use the default stack and do a scaling run. And in this specific use case, I did use JUBE as a test suite basically, and so I ran this script quite often, and the build step is what took the most amount of time. Also the big scaling runs took a bit of time, but for example the small test if it not crashes runs, they are really quick. They're quicker than the build step. So for me, it was really important that I can merge these because I have not only these two sets as I showed here, but I had 7 sets, and I didn't want to replicate the build set 7 times just to limit the amount of runs that I have here. So normally you cannot really merge these. You can either have the full cross product or the cross product with the reduced build set, except when you use the active clause, then you can do that. So for the scaling test, you basically run on the same tree of the full cross product, but you deactivate all the steps where the stack is not the stack that you want to run on. So here I defined the stack by these 3 variables, compiler, MPI, CUDA, and they should have exactly the value GCC, parastation, and nothing for CUDA. And then I'm going to run, and otherwise I'm not going to run. And if you execute this script now, then you actually have only the 5 needed build steps. And for each one, you have the normal run. And additionally, you have the scaling run on top of the stack that we defined here. So you have actually merged it. Now, this is more efficient in terms of runtime. That was my first concern. And then kind of later on, it became clear that this has more advantages than just being more efficient with time. It's also much more maintainable. And that we will see in the next example, where I basically use the same feature again, but for a different purpose. So here, I zoom out a little. We had this run in this build set, and now we have also a submit step. And for me, as a developer, these sets are all independently dealing with different things. The one with the app-specific parameters, the other one with setting up the environment, the third one was job submission. So I don't really want them to be too much dependent on each other because, as I said, I have 7 different studies. And when I write a new study and I only want to change the run parameters, and suddenly something breaks because there's some dependency to the other sets, then I fix this, and then one of the other 6 studies that I've already done breaks again. Like this happened to me a few times before I figured out that I can do it differently. So before this would be my dependency. I would have, or before I would probably have build it first and then submit on top of it and then run on top of build and submit. But what I really want to have is the other way around. I want to inverse my dependency. I want to say in the run, for example, use GPUs. And then this is a parameter that I give to my application. And then the build and the submit parameter sets. They should be smart enough to know, hey, I want to run with GPUs at the end. I need to give the values that are applicable to GPUs. So the build should additionally load the CUDA module, and the submit should submit to the GPU partition. And I don't really want to define this because it is one of the things that these JUBE dictionaries are obvious for. Every time I have GPUs, I want to submit to the GPU partition. It doesn't make any other sense. So, but before I would have to explicitly write. Now, if you just used this in a dictionary, then it will not work because you have created circular dependencies. Because the run is now dependent on the was dependent on the build. As I said, this was my default setup. So in run, I would use some values from the build set. And now in the build set for this CUDA part, I use something from the run set. So I either have to factor out the CUDA specific stuff that I get rid of these circular dependencies, but this is really breaking with the theme of the run set, or do something else and breaking it down into too many small parts at some point also becomes hard to understand. So if you show this script to a colleague, he will be like, I don't know, every time I change something about your script, it changes, so you take it back. I don't want to deal with it. So how do we fix this? How do we get rid of this circular dependency, but still have the implied dependency, let's say? The idea is that all of them are independent. All of them have their GPU or CUDA variable, and inside the set, they depend on these variables. But the value of the variable can be synced with the active clause. So you have something like with GPUs equals with CUDA, and then it's through this synchronization, it's clear that the build will do exactly what is expected if with GPUs is true, but it will depend only on with CUDA, so it has no direct dependency on with GPUs. Now one more, and I try to speed up a little bit. One more idea that I used in the script that I show at the end is smart defaults, and I've already talked about it. So you define one value, and then all the other values that have to change with the value, you encode into the scripting parameters into a smart way that they figure out what they need to do. I have put this to a format for me that's easiest to add new studies. If I put all this smartness into my script that I call default XML, and all the parameter sets that I need to do the whole workflow are defined. So environment, build, run, submit, anything. And it has default values. So it has like default, I build this, and I run like this, and etc. And then when I want to diverge from this, I overwrite just the part that I want to diverge. For example, in my study XML, I overwrite the run to execute different runs. And when I do this and follow the principle that I had before, that they're all not direct, like all the dependencies are loose, yeah, or they are through the active clause, then they cannot break. They can never break if you just override a run set or a build set or an end set. If you override one of them, it cannot break. It will not become a state explosion. You will get as many more states as you asked for in the study XML. And it's super concise. And it's a part. So initially I planned to show multiple scripts here, but I have them in the background. We can still go through them if you want. But I think lots of code in front of your eyes, especially considering that many are still rather new to JUBE, I think it's not really helpful. Maybe we can instead have some more examples in the online tutorials, like full examples. So instead, I will have this example that I talked at the end in more, and then yeah, we can go to the question session. So here is all the three concepts in place, like the loose coupling, the smart defaults, and so in my main JUBE script, if I want to add a new study, basically only add a step for the running, basically for the run step. Define on which kind of build stack here I want to run. Yeah, I synchronize the CUDA and the stack, and then I define for my concrete study what do I want to change in comparison to the default run. Yeah, and here, for example, for this layer test, I wanted to change only one variable called messaging layer. That's something that my app understands. And this is really it. Like, this is not a simplification. This is the complete, let's say, Git diff that you see if somebody adds a new study. And everything else is taken care of. So, for example, here, as soon as the value is CUDA, this is run on top of the build that is with CUDA. And if it's not, then it's a run of the other one. If it's, for example, UCP, it sets some additional environment variables for UCP to be efficient, etc. This is all in my default script, and I don't need to take care of it anymore. And yeah, for the slides, that's the end now. And then, as I said, I have in the background, I have more scripts if you want to see them. Yeah, we also have some more questions maybe. So thanks for a lot of the slides to Sebastian Lewis, who is not with us anymore, but in the team. But the basic feature slides, especially from him. And we are through with this talk now. So thank you for your attention and questions, and maybe also tell me if you are still interested in looking at the advanced example code in full, or if you think this is not necessary.
There is a question in the chat. Do you have any slides about alternative solutions to JUBE? And how does JUBE compares to them?
No, I don't have a slide. I can try to think out of my head. I mean, anything that is calling themselves, let's say, a workflow engine or a description language is probably an alternative. For example, if you're already in the context of CI/CD, then, well, CI/CD has also, let's say, some steps, and in the steps you can execute scripts, but there's no notion of this whole parameter thingy going on. And I think that is probably the same for general purpose workflow engines, that they do take care of the workflow, but you have to see if you can encode the meta information that in this case is the parameter space into them. Yeah, and Then there are some very specific features, of course, in JUBE that we encounter while benchmarking that you might never encounter if you do other stuff with workflow engines. Yeah, so I don't have an overview of alternative things that people would use instead of JUBE. Maybe Thomas or any of the JUBE users, what have you used before? As I said, our experience is the most common things that people use instead are their own scripts that they have written themselves, be it Python or Shell. So of course, JUBE is Python. You can just write your own version of JUBE, or you can have a shell script that takes the parameter definition and then runs your workflow. So this is what we tend to compare it to.
Excuse me?
Yeah.
If I can maybe mention, I can imagine to do the same thing with Ansible, but the JUBE is more specified for HPC workflows and execution, and that parameters is a really big plus for the tool as it is. So I'm looking forward to try it. Thank you for your introduction, Yannick.
Yeah, also thank you for your input. I will check out what Ansible is and maybe do such a comparison for our website or something.
Are there any other questions?
So it was more in the basic part. There was this submission script template for Slurm where you have some section with -env, preprocess stuff. And what do you put? Where would you put setting the frequency of the CPU or changing kernel settings like transparent huge pages or ulimits?
Yeah, I think you're quite right. I would probably put this in env. So yeah, you can decide for yourself. It is completely equivalent if you put it in env or in pre-processing. It doesn't make a difference. You might, even if you have some reason why you think it's better there, put it into the starter or something like this. It's just text submission, so you can put it anywhere where it doesn't break the format. For me, I would consider this an environment thing, unless it's something that you need to execute on the node. I just noticing like CPU frequency, you probably cannot do that from the master node, but you have to do it on each node. So then you either have to, instead of starting your application directly, you can start a wrapper, and inside this wrapper then change the CPU frequency. Or you can probably with srun make this wrapper script oblivious with the one-liner. I think there is such thing as a --wrap.
There is a clutch tool also that can run on all the nodes you specify.
Yeah. But I would say this is a good example where you probably can think of how would I write the job script myself if I write it from hand, and then okay, where did this code end up? How do I get it easily into the template? Yeah.
Thanks. I was not asking for a definite solution, just your opinion on the topic.
Yeah, if it's anything that you can set from the master node, so like environment variables, etc., or writing into a configure file or something that changes things, then I would put it into env, and if this is not possible, if it has to be executed on the specific node, then wrap it in the execution command.
I mean, the advantage of JUBE is that it's highly flexible and has multiple paths to solutions. So there's not just, sometimes you have multiple paths to achieve the same thing. And it depends, of course, as Yannick mentioned, on your setup. How is your system set up? What do you have to run in which state of your workflow. And if it's an environment variable, if you have to execute it directly, indirectly, if you have to pre-process something. So this can be all configured as you need it.
Yeah. So I guess it was already clear from the answer, but env, pre-process, and measurement, this is something that is on the master node, and then only after the srun, so executable and arts executable is something that you can address each node individually. So one clean solution is make executable a wrapper.